Hello and welcome everybody to our first solution for the DMC 2020. We are a team of 3 students from the University of Bonn. Our names are Uttam Kumar, Florian Huber and Maurice Adrops, and we participated in this competition as part of the BDA lab course from Professor Dr. Emanuel Müller. On the first slide, we can see a nice graph that shows us the total orders per day over the whole training period. We actually accumulated the orders over all particular items. So this is a really general view that you can take from here. But there are already a few insights we can gain. The first one is that the data itself is really hard to predict. So even for a human, you cannot say how the next day will look like. And we can see a slight tendency of rising orders over time here. When we go on the next slide, we can see this even better because here we have basically the same graph, but this time we aggregated bi-weekly and not daily. And now the task looks a lot like more easy. Because the graph is smooth now, and we gain another really big advantage from this fact, and that is that we can now handle the time series problem with time-dependent features without having to bootstrap and therefore add uncertainty that the model cannot handle in the end.
And then we go on to the feature engineering. So after we decided on what basis to aggregate our data on, we decided to do a very feature-heavy approach. And our most important feature is whether an item is promoted on a certain day or not. The item that we came up with to identify these promoted days is the following. We perform a certain mapping on the daily item orders, and then apply a z-score transformation to the results of these mappings. And we mark the days with a z-score greater than or equal to 2 as promoted days. In the graph you see down here on the slide, we did this for item ID 1, and you see the peaks in the item orders after the mapping and the z-score transformation correlate with the real items peaks and are therefore marked as promoted days. On the next slide, we see that overall our promotion feature is successful. So in the graph, you see how many promoted items are there per 2-week slab, ending on the date that you see on the x-axis. And we see a rising number of promoted items throughout the month, which correlates with the total trend of more orders over time. And we see that our promotion feature is actually consistent with the number of promoted items that we have in the simulation period, as is seen as at the last dot of the graph. When we go on to the feature selection, overall we have a total of 68 features used in our models. And in the bar graph below, you see the top 10 features with regards to their feature importance. As already said, our promotion feature is a very important feature, therefore it is number 1, and we see many features that have something to do with promotions. In this graph, for example, on the second place, how many days is an item promoted in the current 2-week slab? What is the average of the promoted item orders, and so
on. So moving to the models that we used, we actually trained our extremely randomized forests being our first model, and did same on XGBoost, that is our second model. We optimized both of the models on the training data and using grid search CV. And then on the benchmark period, we compared which model is performing better on what particular category. So once we had this data, we combined the results similarly for the simulation period using both of our models to give best results, you can say. So this is for the model part, and then yeah, thanks a lot for having your attention here. Please make sure also to check our second solution on the DMC website, and for further questions you can just reach us via the emails which we have provided. Thank you.